Thanks, Kesar. That's a nice introduction. Um, I'm Arunansu Pattanayak, like you said. There is my personal website, arunansupatnayak.com, if you want to get in touch with me. I like to describe myself as a fractional CTO. Like these titles in different companies, it can be misleading. Not many people understand what it means. Like my current title is a technical specialist. But what I do is I align with the technology leaders at companies. So I become their trusted advisor and I advise them on technology strategy for the company. So I think fractional CTO is a generic term that kind of describes what I do. So somehow, oh, maybe these are read out. Okay. So I'd like to start with a statistics based on research by IBM that 75% of the CEOs believe that organization with the most advanced generative AI will have a competitive edge. Now, the emphasis is on advanced because this talk is going to be about what is the state of the art, the most advanced use case of Gen AI, and kind of to form the baseline for that is, why do you want to have the most advanced implementation? Because by now it's not a secret that, people who use AI, people and organizations who are able to leverage AI are having a competitive edge over those who don't. And even the people who are leveraging AI, it's how advanced is their implementation. That's what differentiates those organizations compared to others who might be using just vanilla out of the box AI implementation, right? So what does AI or generative AI do for you? The most known use cases are content generation. That was the very first use case of generative AI that people started creating images, blog posts, social media posts, generating documents, templates, right? So that was the first use case of Gen AI. Then, it matured more into a specific domain like code generation. So you can use Gen AI to translate one programming language to another or get code hints on a particular task, create, unit functions, test cases, things like that. And then there is semantic search. So, Gen AI helps you, advance your search from a keyword-based search to, going into the meaning and intent of the search to do more semantic search. And of course, if you can ask question on a data, you can also summarize the data. So summarization was another use case, right? Now, going back to whoever has the most advanced Gen AI implementation has a competitive edge. So what are the different levels of complexity of implementation people have in Gen AI, right? Right at the bottom you have the summarization, question and answer. This is the standard chat GPT that everybody is familiar with. That's the simplest implementation of Gen AI, right? A little bit more complex than that is data driven decision making. You can use a RAG pattern to connect data sources to your Gen AI model, and you can either fine tune it or just keep it as a RAG pattern so that your Gen AI model is able to use that data to give you more personalized information. So that's a little more complex than using the vanilla chat GPT type of model. A little bit above that is more personalization. Along with using the data, you can also add more system prompts, add more filters, add specific accents that that would make your AI more personalized. It's a very common use case in every organization today that they are building their own custom GPT that is trained on their organization data and is filtered and customized according to their policy, right? So that's a little more complex than using RAG pattern. Right? The most complex is using Gen AI to create automated system or automate a business process. And that's what today's talk is going to be about, how to automate your business processes using Gen AI. Okay? So when it comes to automation, the automation is in GenAI is done using agents. And what are agents? Agents are nothing but applications, but they are not your traditional application. Agents are intelligent applications. So they are context aware. They respond to natural languages. They have decision making capability similar to humans. So that's why they are AI apps, right? So this creates a paradigm shift in how apps are being developed, right? In future, all of the apps are going to be AI apps, right? If you look at a traditional app, they are constrained in the interactions, right? So you have a UI, it gives you a few options. Those are the only things you are allowed to do, right? And based on each input that you give, there is a hard-coded set of things that it does, and the input and output are predetermined, right? So, and that's very, first of all, it's overly simplified. On top of that, it's also a complex implementation because as you need to add a new functionality, which means you need to go add something in the UI, add something in the middle tier, add something in the back end. So, even as adding a simplest feature in the current app takes a big project implementation, right? But with the intelligent apps, your UI is simplified because it's just natural language, right? And your data you can keep adding, and the AI just kind of self adapts to your new data, right? So adding a new feature or functionality is simply as it's just as simple as having it recognize a new type of prompt, having it recognize a new type of data, right? So adding that new feature becomes increasingly simple, and yet this is very effective and very powerful compared to what the old apps used to be. And in today's talk, we'll see more about the design patterns and tools behind that. In Microsoft, Copilot is Microsoft's name for Gen AI implementation. The If you look at the tech stack around Copilot, it's divided into, you have the Copilot AI stack, which is your model and your prompt, the software stack, right? Then you have the hardware, which is the Copilot devices like Windows or mobile devices, IoT, right? And then you have your Copilot, which is the interface that you have that you interact with. It could be something that is living on the side of an application. On Windows, you have your Copilot button, so it's the interface that you are interacting with, right? Now, talking about that, Copilot AI stack, right? Within Azure, the AI stack is, two part. So the Copilot, there is a Copilot Studio for low code, no code, and then there is the Azure AI Foundry for more of a pro code, right? And it's built on the Microsoft Cloud. It uses the infrastructure of Microsoft Cloud, the data. It's pre-trained on Microsoft owned data, plus it allows you to augment using your organization data. And Azure AI Foundry is the software stack that is used to build GenAI agent or custom copilot. The AI Foundry has an SDK called Foundry SDK. So if you need to be completely pro code, AI Foundry gives you, within the portal, a quick way to kind of spin up your app, and then you can, download the code, and rest of the implementation you can do using pro code. And then you have tools like Visual Studio, GitHub for source control repository, and GitHub has a lot of template libraries on building copilots and agents that you can get started with. Okay. And if you need to build a business application in a more low code environment, then Copilot Studio is your tool, and it has built-in connectors. As you can see, there are over 1400 connectors to all different types of apps. So within a business workflow, you might say something like, okay, send a newsletter, or publish this in social media, or connect to Snowflake and get this report, or publish this YouTube video, right? So there are all these connectors to all the third-party services. So building an agent to do something is simply as simple as making these connectors available, and then running your Copilot. That makes your Copilot agent an easy to create. So a business user could use Copilot Studio to create an agent that performs different business tasks, like sending an email, adding something into a calendar, extracting something from a sales call to create an action item, right? So all of these could be done using Copilot Studio by a business user without writing much code. Right? Those who need more pro code, you want to get into the details of exactly how the data is processed, exactly how the action is taken, how the agents spin up task, how exactly each layer of execution happens, how the memory is managed. For that, Azure AI Foundry is your tool, and it comes with a lot of things built in. Of course, you have your foundational models, the LLMs, and you have all the open source models and all the partner models from like Meta, NVIDIA, right? And then you have your each task specific model and industry models, right? You also have Azure AI Search to build that quick RAG pattern with creating indexes and building embedding. And then what's new is the AI agent service. So the agent service helps you kind of build the agent in a more managed way. So you don't have to write much of the plumbing code for building an agent. So the agent service kind of, is a managed environment that can help you get started with building your own agent much quickly. It was announced in Ignite. It's still not out, but it will be out soon. All of this is again built with AI content safety, so security and privacy is kind of built into it. So, and the tool obviously supports it. And then you have Visual Studio as your tool, and GitHub as source control. Plus, GitHub has a lot of code libraries that you can use. Right. So this is the AI agent service that I talked about. It helps you kind of rapidly prototype your AI agent, but in a pro code environment that you get started quickly, but you can customize it. It supports multiple model, and for security perspective, you can bring your own VNet and connect using your Entra ID or whatever authentication you use. Now, this agent service is kind of evolution of an open source project that Microsoft contributed to. It's called FLAML, right? It is like, I think, fast language auto ML, right? But AutoGen was the first generation of framework that Microsoft created for building agentic AI. Now, AutoGen still exists, and the recommendation is if you are kind of building something quick and dirty for research purposes, AutoGen can help you get started quickly. But if you are building something that you want to deploy to a production environment, then go with the AI Foundry SDK. Okay, so we talk a lot about AI agents. So what exactly is an AI agent and how is it different, right? So there are a few characteristics that defines what an AI agent is. Number one is autonomy, right? It's something that can take action on its own without a human oversight. Then there is reasoning. It has its own way to reason and make decision, right? Then there is adaptable planning. So as things change, it's able to reevaluate the metrics, reevaluate the strategy, and change the action plan and execute differently. it's context aware. So there is context understanding in terms of, it knows what you are saying and in what context you are saying, right? And of course it has action enabled, that it not only just trying to listen everything, understand everything to give you an answer, it's also able to take action, like, book a flight, or um, create an event, something like that, right? There are a few design patterns that already exist. And keep in mind, now, agent as an app is not new. There are people who are already building agent. It's not something that Microsoft just created. So there is already, people are building agent using raw code, right? Now, what's happening now is that Microsoft is building the best practices in terms of agent service. So a lot of things are going to be more rapid prototyped, and there are some best practices that are going to be implemented. There are few design patterns that already exist in terms of creating agent. The simplest form is the RAG agent. This is your, quick question answer agent, where it's able to plug into a knowledge graph and just answer questions, right? Then there is code generation agent, similar to GitHub Copilot, that it's, you give it a context, you give it, a task, and it's able to write code, right? Then there is multi-agent system, similar to in the application world, we say multi-threaded programming, right? So this multi-agent system is broken up into multiple agents that work together collectively to perform a collective task. Now, these multiple agents can further be defined within different domain, and that's when they are called multi-domain agent system, because each domain can contain multiple agent, and each domain is kind of categorized as a functional domain. So going back to, like, in the old days when we did programming, there was something called function driven design, FDD, right? So it's kind of bringing that same thing to AI agent. Okay. So a RAG agent, like I said, is the simplest form of agent. All it does is, you have an interface where you ask a question, it's connected to a knowledge graph, right? So based on your question, it knows the context, it builds a plan, it builds a query plan to query the knowledge graph, right? And as you interact with it, it updates the plan, it compiles and gives you the answer back, right? That's the simplest form of agent, which is like the chat GPT that you are familiar with, you know the next version is the code generation agent, where, you have a human in natural language can say that, hey, I want a code for this, right? And then it goes into its reasoning layer, then it goes into the memory management. So it's kind of evaluating different things, putting it in memory, it's connecting to different tools, it's doing lookup across different sources, and then there is a coordinator that kind of spits out the code back to the interface. Now, in terms of multi-agent system, like I said, think of, a multi-agent system as an agent that is broken up into multiple agent. So, a good example or good analogy in terms of traditional application development is that when we build a complex application, we build microservices that perform simpler tasks that kind of collectively becomes the big application, right? So the agents, in this case, the multi-agent system, each agent is kind of like a microservice. So all of these come to combine becomes a complex task that an agent performs by delegating tasks to each of these sub-agents. Now, those agents can be grouped together into an agent pool, and those pool can be specific to a domain. So there can be like a finance domain. Each specific business domain can have its own domain. Going back to that domain-driven design analogy, so you can have a multi-domain agent system where there are multiple agents grouped into different domain, and they all work together to perform a complex task, right? An example could be a travel booking agent, where that one agent has another agent which is a customer service agent, which is kind of doing the booking and giving the answer, and within that it also has other agent that is only doing hotel, that is only doing flight, right? Or it might be even broken up into one doing the shopping part of it, the other doing the actual booking part of it, right? And it has tools to connect to the transaction system to actually do the booking and connect to the knowledge search to kind of extract all possible options, find out which is the cheaper, what fits into the timeline, right? So all of these are kind of sub agents. They are, and they can be different domains. So there can be hotel domain, there can be flight domain, there can be car domain, right? And there is a customer service domain, and all of these combined together is doing kind of a full service travel booking agency, right? That's an example of a multi-domain agent system. Now with that, my presentation is over.